In order to solve this integral, evaluate this integral, as you can see, you have ln of x on the denominator, you have x times square root of 1 plus ln of x to the second power. What are we going to do? We're going to basically take the quantity inside the radical as your u. Let u be 1 plus ln of x to the second power. What is du then? Du is equal to 2 times ln of x times 1 over x dx. So let's see if we can simplify this guy further or not. My dx in terms can be written as x times du divided by 2 times ln of x. So this guy can be written as the integral of, I have ln of x, on the denominator I have x, then I have square root of u, and then my dx is equal to x du divided by 2 ln of x. So as you can see, you can get rid of x and x, ln of x, and ln of x. This guy in terms can be written as a half integral of du divided by square root of u, which is easy to work with. This is the integral of u to power negative a half du. So you already have 1 over 2 in front of your integral. Now, if you add 1 to a half, you get a half. So you get 2 divided by 1 or just 2 times u to power a half plus constant of integration. You can cancel out 2 and a half. So you end up with square root of u plus c. But what is u? U is 1 plus ln of x to the second power plus constant of integration. Let us evaluate the integral of square root of x divided by 1 plus x cubed dx. So let us use the method of U-sub and take u to be square root of x. In that case, du is equal to 1 over 2 times square root of x dx. So your dx can be written as 2 times square root of x du. So this integral in terms can be written as the integral of u divided by 1 plus x cubed, and for dx you have 2 square root of x, which is basically 2u du. Take a look. Dx can be written as 2u du because your u is equal to square root of x. So here you have 2u du. But what should I do with the x on the denominator? Well, let us isolate x and raise it to the third power. Since u is square root of x, it means that x is u squared. So if I raise x to power 3, it means that I have u to power 6. Perfect. So my integral is now the integral of u times 2u du divided by 1 plus, I have x to the third, which is u to power 6, plus u to power 6. Very good. Excellent. This integral is equal to the integral of u 2 times u to power 2 du divided by 1 plus u to power 6. Okay, so what should I do now? How do I find this integral? First of all, rewrite this integral as the integral of, you can write down 2 in front as well. No one's stopping you. 2 integral of u squared du divided by, now I want you to break down u to power 6 as u to the third to the second power. So write this guy as u to power 3 raised to the second power. Why? Because then we can use another u sub. So let v be u to power 3, dv is 3 u squared du. So multiply by 3, divide by 3, and this guy on top is your dv. So we're applying u sub one more time here, and this is my v. So now the integral is equal to 2/3 integral of dv divided by 1 plus v squared. But we are all familiar with this integral. The integral of dv divided by 1 plus x squared is similar to the integral of du divided by u squared plus a squared, which is 1 over a arctangent or inverse tangent of u over a plus constant of integration. You're already familiar with this. My a in this case is equal to 1, and my u is equal to v. So this integral is equal to 2/3 inverse tangent of v plus constant of integration. But what is v? Well, we have a lot of substitution. V is equal to u to the third. So far, this is equal to 2/3 inverse tangent of u to the third plus c. But what is my u? My u is equal to square root of x. This guy here. I have to write everything in terms of x, everybody. I cannot leave it as it is. So since your u is equal to square root of x, or x to power a half, u to the third is equal to x to power 3/2, or here you have x times square root of x. So this integral in turns is 2/3 inverse tangent of x times square root of x plus constant of integration.